Alright, so here we are with Unit 5, lesson number 6, and we're going to get into something called stoichiometry. And don't worry about the fancy term stoichiometry. Basically, what we're going to be looking at in this lesson is we're going to be looking at chemical equations, and we talked about them a couple of times earlier in the year. A chemical equation is basically the story of how a chemical reaction occurs. It gives you the reactants and the products. In other words, the substances that you start with are called the reactants, and the substances you end up with are called the products. And an arrow is what separates the reactants from the products. And before we get into the actual chemistry part of it, let's just take a look at sort of an analogy of what we're going to be looking at. So let's say, for example, we had a recipe to make bread, and that recipe said that we need 3 cups of flour and 1 egg, and that would give us 4 loaves of bread. What we're going to be looking at in this particular section is, first of all, if you notice the numbers in front, those are the really important things. It says, so first question says, how many loaves of bread is produced if you use 6 cups of flour? So what they're saying is basically if we change one of the numbers in the recipe, how is that going to affect the other numbers? So for example, instead of using 3 cups of flour, what if we use 6 cups of flour? Well, it's a couple of things. It's relatively simple. Obviously, if we start out with 3 cups, but we end up using 6, we've now doubled the cups of flour. If you double the cups of flour, that means that you would have to double everything else in the recipe. So if we used, instead of 3 cups of flour, 6 cups of flour, we would then need 2 eggs, and we would be able to produce, of course, twice as many loaves of bread. We would be able to produce 8 loaves of bread. Let's take a look at another one a little different. It says how many eggs are needed to produce 12 loaves of bread. So instead of worrying about the flour, we're saying, well, instead of 4 loaves of bread, what about if we needed 12 loaves of bread? How many eggs would we need for that? Well, if you look at 4 versus 12, to get from 4 to 12, you're tripling it. 4 times 3 would give you 12, which means if you're going to multiply this by 3 to get 12 loaves, you're going to have to multiply, in fact, both of these numbers by 3. So to get 12 loaves of bread, you're going to need 3 eggs. And that's basically an analogy of what we're going to be doing. But obviously we're not going to be in the unit talking about flour, eggs, and loaves of bread. But it is a relatively good analogy. Unfortunately, it's not always this easy. For example, when we started out with 6 cups of flour, well, what we could do is say, well, what about if we wanted to do 4 cups of flour? How would that affect the other numbers? It's not that simple. You can't just say because we went from 3 to 4 cups, in other words, went up 1 cup of flour, we'd have to go up 1 egg. It doesn't work that way. And that's what we're going to be looking at. So that's where it gets a little bit more difficult. So let's get into, again, these are the answers. So these are called, by the way, mole to mole problems, or you can sometimes look at mole ratios. Now, we're not going to worry about balancing equations. We're going to do that later on. But if you take a look at this very simple chemical equation, here's the arrow. The arrow, again, is what separates the reactants from the products. Notice in this case there are 2 reactants. They're separated by a plus sign. That doesn't mean you're adding it. That's just how they separate them. But there's only 1 product. There's no set number of reactants and products. You could have 2 on each side. You could have 1 on 3. You just have to remember that the arrow separates them. So if I'm going to give you these are called, of course, coefficients, and these numbers here are called subscripts, and we'll learn about in the next unit in more details about them. But basically, what you would say is this would be read: 2 moles of hydrogen. Notice hydrogen's diatomic, reacts with 1 mole of oxygen, and the arrow says produces 2 moles of water. So those are the numbers that we're looking at, 2 H's, 1, and 2. So they're asking you, what is the mole ratio of O2 to H2? So in other words, what are the coefficients? The ratio of O2 to H2 is 1 to 2. It's that simple. Now here's where we start to do what we did on the previous slide. Let's say, for example, it says if I want to burn 5 moles of oxygen, how many moles of H2 gas? So in this thing, we're not really worried about the water, we're worried about the 2 reactants. So what we're doing is we're going, instead of 1 mole of oxygen, what about if we had 5 moles of oxygen? What would that do to this number? Well, this is a relatively simple one. There's a couple ways you can go to it. Well, notice how the hydrogen is 2 and the O is 1. That means the H is always going to have twice as many as the oxygens. So if you take that into account, if this is going to be twice that and this goes to 5, this would have to be, of course, 10 moles. You could also say, well, if I go from 1 to 5, that's multiplying this by 5, I'd have to multiply this by 5. So the answer, of course, would be, would be 10 moles of H2 gas. For some reason, it didn't write it. Okay, let me go to the pen and pick the pen color. Blue. Okay. Here's the next one. So if you look at this equation, it says how many moles of NH3 are produced when 0.6 moles of nitrogen reacts with oxygen. So we're going to just put the numbers in to balance it. Normally when you balance something, you wouldn't put the 1 here, because remember in chemistry we generally do not write 1s. Notice here the N, there's no 1 here. But for now we'll leave the 1 there. So what's going to do is we're going to change one of these coefficients and ask what is it going to do with another one. So it says how many okay, it says how many moles, what's going on? So it says how many moles of NH3, so we're only looking at the NH3, are produced when 0.6 moles of nitrogen reacts. And we're looking at the N2. So the H2 has nothing to do with what we're doing here. So what coefficient or what number are they changing? Well, how many moles of ammonia are produced when 0.6 moles of nitrogen? So we're going to change this to 0.6. What is that going to do to the 2? Well, this is an easy one. Notice that the ammonia is twice the nitrogen. So whatever this is going to be twice that. So if you double 0.6, you're going to get 1.2 moles. So the answer to this would be 1.2 moles of ammonia. Okay. Next is at the bottom. So here's our balanced equation. 4 moles of solid aluminum, the S stands for solid, you might want to write that, reacts with 3 moles of oxygen gas, and it produces 2 moles of the compound known as aluminum oxide, and it's a solid. This is an ionic compound because that's a metal, that's a nonmetal. We don't need to use the stock system here, remember that, just a review, because aluminum only has 1 positive oxidation number. So let's see. So it's saying how many moles of aluminum. Now it says aluminum, not aluminum oxide, so this is the aluminum, are needed to form 3.7 moles of aluminum oxide. So here's what we're doing. We're changing this from a 2 to a 3.7. And here are the two coefficients, a 4 to 2. Well, again, notice how the aluminum is always twice the aluminum oxide. So whatever we change this number to, this is going to be double that. So doubling 3.7 would give you 7.4 moles of aluminum. And these are two very good examples of mole-to-mole problems. Okay, so that's the end of this lesson. And again, if you have questions and we are going to do practice problems, please make sure that you bring that up.